Electricity has many uses. How did your day start? Did an alarm clock wake you? Did you turn on a light? Did you eat something out of the refrigerator? Yes? Then you used electricity. Think of all the things in your home or school that uses electricity. What do they do? Devices that use electricity change electrical energy into other types of energy, such as light or heat. We use electricity to heat our homes and cook our food. We also use it to light our rooms and to keep foods cold. A computer changes electrical energy into light, sound, and heat. When you turn on a computer, you see pictures and hear sounds. You feel heat coming off of it. A computer can be plugged into an electrical outlet. It can also run on batteries. How do the objects on these pages change electrical energy? Many electrical devices have electric motors. An electric motor is a machine that changes electrical energy into energy of motion. An electric fan uses an electric motor to move air. A refrigerator uses an electric motor to keep foods cold. What other objects in your home have electric motors? Any electric devices that makes motion probably does. Magnets and magnetism. You can feel the force between two magnets. You feel magnets pull together and you feel them push apart. How do magnets work? Magnets have been used for thousands of years. A magnet is an object that attracts iron and a few other metals. Magnetism is a physical property of matter. Magnets push and pull because of their magnetic field. A magnetic field is the space around the magnet where the force of the magnets acts. Each magnet has two ends or poles. A magnetic pole is the part of a magnet where its magnetic field is the strongest. One end is called the south-seeking pole or south pole. The other is the north-seeking pole or the north pole. An N pole or north pole and an S pole or south pole are unlike poles. If you place unlike poles of two magnets near each other, they attract or pull towards each other. If you place two N poles or north poles near each other, they repel or push away. Two south or S poles push away too. Like poles repel each other. The picture above shows a bar magnet. The iron fillings around the magnet show the shape of the magnetic fields. Where do you see the most iron fillings? They are at the S or south and N or north poles of the magnet, which are where the magnetic field is strongest. Where do you see fewer iron fillings? The middle of the magnet has fewer iron fillings. The magnetic field is weakest there. The size and the type of material used to make a magnet affect its strength. Electromagnets. Electricity and magnetism are related. One can produce the other. Suppose you slide a coil of wire back and forth around a bar magnet. When the ends of the wire are attached to a light bulb, the bulb lights. Moving a magnet and a wire near each other produces an electrical current. If magnets produce electricity, can electricity make magnets? Yes. A wire with a current in it wrapped around an iron nail makes a magnet. A device in which current produces magnetism is called an electromagnet. Huge electromagnets are used in junkyards. The operator swings the electromagnet over a pile of junk. He turns on the current. All the iron pieces are attracted to the magnet. Turning off the current stops the magnetism. Today, every electric motor contains at least one electromagnet. You can also find electromagnets in telephones, doorbells, speakers, and computers. Doctors can use electromagnets to take pictures of the inside of your body. Why it matters. Generating electricity. We use electricity every day. How does it get to our homes and schools? Inside a hydroelectric dam, the mechanical energy of falling water is used to turn generators, which change mechanical energy into electrical energy. Electricity generating stations, also known as energy stations, may use water, coal, or atoms to produce the electricity you use. A magnet spinning in a coil of wire is a generator, a device that converts mechanical energy to electrical energy. Some energy stations use falling water or wind to turn generators. Other stations convert sunlight or solar energy into electrical energy. These resources are called renewable resources because they can be replaced quickly. Most energy stations burn coal or other fuels to heat water. The water rises as steam, which turns to generators. Coal is a non-renewable resource that will eventually run out. That's why it's important for us to conserve or use less electricity. Windmills have been used to grind grain or pump water. Today, wind turbines generate electricity